with Neo1, and today I'm going to demonstrate how you can use Neo1 to write, compile, and test your smart contract for the RC1 N3 Neo blockchain. So let's just get started. This is all going to be straight from scratch, and we're more or less following the tutorial from the current Neo1 website, which is at neo-1.io. So I already know all this more or less. I'm going to just go ahead. So here I am in my terminal application, iTerm, just on the desktop. I'm going to get started by using Create React App to get our project started from scratch. So you can see I've already done this before. RC1 demo with this template TypeScript. So we're starting with TypeScript, which is our preferred environment here at Neo1. You see, it just takes a few seconds to get installed. If this doesn't work for you, just look up create-react-app. You'll see it's a Facebook tool for bootstrapping a React application. It just kind of creates a bunch of boilerplate for us, and this makes it easy to get started really quickly. And no, you do not have to use React. If you use Create React App, you do not have to use React. You do not have to have a front-end application, but it's a good way to get started. So while we're waiting, I just explain that we've been working really hard on our tooling for the new Neo blockchain, which is being called N3. This project will be demonstrating for the RC1 release. So that's kind of the benchmark on the way to the final mainnet for N3 for the Neo blockchain. Okay, so you see that worked. You see on the desktop we have Neo1 RC1-demo. So change directory to there. Okay, let's open that up with VS Code. Bring this over here. Boom, boom, boom. So we're going to add a bunch of Neo1 packages. Our preferred tool is Yarn. You can use npm as well. That would be npm install. You can see I've already done this before, so it's going to be at Neo1 CLI at pre-release. So all these are going to be the at pre-release tag on npm, which as of this recording should be usually the package will be at version 3.3.3-RC1, which is what you'll see on npm. So I'm going to do that, and that's going to add all these packages, and that's also going to take a second. The main thing it's going to install is the Neo1 CLI package, which is how we're going to be interacting with Neo1 today, primarily. So Neo1 provides a full suite of APIs, which you can use on your own to construct your own tooling however you'd like. We have many layers of APIs up and down the stack, but the top layer is going to be the CLI, which you can use to kind of do the basics really well, and Neo1 will take care of all the other setup, all the compiling, deploying, testing infrastructure, and client API generation, which I will demonstrate here shortly. Should also note that you will need to have C#.NET installed, specifically version 3.4, I believe, 3.1, and I'll check that in a second. Let's see. This is my completed demo. You're going to want to have 3.1.401 installed. So while this is running, I'll just show you should be able to do .NET, should have .NET installed, and then if you want to make sure you have that -- list SDKs, you can see I've got 3.1.401 already. And that's we need to use that for the C# in the node. Which we're gonna need this later. But right now we're just starting with this as this gets going. There we go. Okay, so I go here. We should see our packages right here. 3.3.1-RC1. That's what we want. Good. So the first we're going to do is just yarn neo1 init. So this is using the neo1 CLI init command, and this will initialize our neo1 project. I'll show you what that does in just a second. As it does, this should take more than a second. Okay, so this problem, this is what you'll run into. This is, I have, you'll see right now I'm using .NET version 5, and that's not compatible with neo1. So what you do is in here create a global.json, and it's very simple. You're just telling .NET that in this repo you want to use a specific version, and for us that's going to be 3.1.401. Boom. So now you do .NET version, you'll see 3.1.401. Now try the init command again, and this should work just fine. There we go. So I'll tell you what it did. Created a neo1 config file, created a sample test, a sample tsconfig, a sample contract, and updated your tsconfig.json. And there you go. Run neo1 build next. So I'll show you updated, just added this excludes to exclude our contract files. Added this neo1 config in the root. You'll see this is our default configuration for everything neo1. You can see documentation in here in the comments to see what each of these does. But all this should be fine. I like to set these to true. This is for when we compile output files from our compiler. When we're compiling our contracts, that'll produce a JSON output, the neo executable format file, a debug file with opcodes, opcodes, and another debug file for other tools to use. You'll see in here created a hello world smart contract, just a very basic one. Create our tsconfig for our smart contracts, and that's about it. Oh, and then in source, and we created this test. It's a very, very simple test, which won't work right now. We'll get to that though. So then you want to go to contracts. So this is where your contracts are going to live, this contracts folder. And we're going to create a new one, and we're going to create a token contract today. Test token.ts. I'm going to delete this hello world contract. I need that. We don't need this until later. So let's see. So I'm just going to copy and paste something I've already written, a sample contract for this. It's pretty long. This is a standard, basically what a standard NEP17 token contract would look like in neo1. This is almost completely to the NEP17 spec. But every smart contract needs to extend smart contract, which you import from neo1 smart contract. It's got to have an owner, a name. Actually, I don't think it has to have an owner, but it has a name, decimals, and symbol, TT, test token, and 8 decimals. These properties is also required in a neo1 smart contract, and this is kind of advanced, covers permissions for your smart contract, who and what contracts can call your contract and what methods and stuff like that, but that's a little bit more complicated. You have a basic constructor. It's going to set up the owner. It's going to issue tokens. We have map storage to keep track of balances, map storage to keep track of transfers, our current supply, more advanced notification mechanisms. We've got the total supply method, balance of method, transfer method. These are other private methods. I'm sorry, not private. Issue method. So yeah, this is a NEP17 contract, more or less. And so what we're going to do next, after you've written your smart contract, you have it in the contracts folder. What you're going to do next, usually, we'll start with the compile command. So neo1, note that you can always do neo1, yarn neo1 help, and it'll tell you exactly what commands are available to you and what they do and the options available. So let's see, we did init. Right now we're going to do build. That's the primary command you're going to be using in neo1. Yarn neo1 build. This will read the contracts, compile them, and then spin up a local development network and deploy your contracts to that network. And there we go. So you can see here we've created this new neo1 folder. For our test token, we've got the contract definition. This is the address of your contract on the local development network. We've got your manifest, which we'll come over to. And then this is going to create your client APIs, which we'll get to. Here you can see this is the manifest of our contract with all the methods, events, parameters. For the methods, this kind of defines the metadata of your contract. The supported standards, permissions, name, groups, trust, all this information you probably don't need. These are the types for our generated client APIs and test APIs. You see our generated client. And then our with contracts, which is going to be used to test our contracts. So now we're going to go to here. We're going to create to test our contract, we're going to create a test token, test.ts. And this is where we're going to test our contract. So I'm just going to copy and paste over from what I've already written. You'll see we import with contracts from our generated test file. And this does a lot of work for us. So this is going to take our contract. It's going to spin up a local development network, compile our contracts, and then deploy it to that network. And then all within this function, it's going to give us the generated object, which represents our smart contract, which we can then call methods on. And I'll show that in just a second. Our client, network name, and our basically our wallet, our user account ID, our master wallet account. So you can see here, we're focused on this test token object, and this is how we're going to call our contract method. So we have a name, and this is effectively a method to get this. This is just a constant, always going to return this string. So if you go here and call name, it's going to give us this. It knows it's a string because we know what the contract does, and the generated types will tell you in TypeScript that this is a string, and what we expect it to equal test token. Same here, going to call. These are all asynchronous methods, so put them in a promise.all. Call the decimals. What is this? It's a big number converted to a string, and it should equal 8. The symbol, we know it's a string. That should be equal to TT. And this is we're just adding a wallet to our client. Same over here. You can see we're calling test token, the method called balance of, which if you read the types, it's going to take an address in the form of a string and return a big number, which is a number. So we give it the master account address, what is the balance of, and we expect it to equal 100. Same here, total supply. We're just going to get the total supply. You can see it knows it does not take any arguments in this method. So it's going to call total supply and give us the expected value. And you can see I've created a bunch of tests for this. More balance of, after we've made transfers, what's the total supply? Should have gone down. Balance of our zero key, and all this should work. So let's just test this with contracts by running yarn test. Okay, so this will happen when you're using Jest. And you have a long test, which we do. We have a lot of asynchronous methods. We have to set up the node. Takes a few seconds for Neo1 to do that. So I believe we want jest.set timeout and just set it for 20,000 milliseconds, which is 20 seconds. Let's see if that does it. And there we go. All the tests passed. And so that's a very basic demonstration of how you can use Neo1 to write your contract, compile it, and test it with Neo1 with these APIs we provide. And there you go. We'll see you next time.